Welcome back to Talk Tensors. The show where we kind of like go on deep dives into the latest and greatest machine learning research. And today we're going to be talking about a paper that's got the anime community super excited.
Oh, yeah.
It's called MangaNinja. Line art colorization with precise reference following. I mean, the title itself is pretty cool, right?
Definitely caught my attention.
So get this. The paper claims that it can automatically colorize line art. And not just in a basic way, but with super high accuracy, by using a reference image. We're talking matching colors to the level of individual brushstrokes.
It's a huge step forward in a field that's, had this problem for quite some time.
For sure.
Traditional methods, they struggled with those fine details, and they often produced results that looked kind of,
A little flat.
Yeah, a little flat.
Yeah, they lack that artistic finesse. So before we, unleash our inner ninja and break down MangaNinja, let's kind of rewind a bit.
Yeah.
And trace the evolution of, line art colorization so we can really understand the context of this, groundbreaking research.
Makes sense. Early attempts at line art colorization were really reliant on, manual techniques.
Right.
People had to meticulously pick colors and, painstakingly fill in every section of a drawing. It was such a long and tedious process.
Oh, I can only imagine. Like the hand cramps?
Yeah.
But luckily, technology came to the rescue, and we saw the emergence of more automated approaches.
Right.
Remember those early tools that used algorithms to identify and colorize regions based on simple color palettes?
Yes, but the results were
great.
They lacked that subtlety and nuance, of a human artist.
Right.
The colors often appeared blocky and unnatural, and anything beyond basic shapes, it just didn't work.
It was like a far cry from the vibrant and dynamic color palettes that you see in hand-drawn anime.
Right.
But then came deep learning, and things got really interesting.
Yeah, researchers finally had the tool to achieve, intelligent colorization.
Yeah. And early deep learning models showed a lot of promise, but they still had trouble with accuracy and fine-grained control.
Yeah.
They could get the overall color scheme of the reference image, but they often missed those little details that really make anime art captivating.
Yeah, it was like painting with a broad brush instead of a fine tip pen,
Totally. And that's where MangaNinja comes in, wielding its katana of innovation, ready to revolutionize the field.
Yeah, it really is a turning point in this quest for precise and artistic line art colorization.
So let's sheathe those katanas for just a second and delve into the heart of MangaNinja. The paper talks about a dual branch structure that utilizes two specialized neural networks called the reference U-net and the denoising U-net.
Think of these units like, highly skilled artists, each with their own unique role in the colorization process.
Okay.
The reference unit is like the master observer. It carefully analyzes the reference image, extracting its colors, patterns, and style, like an artist studying their subject before they even pick up a brush.
Right. So it's all about really understanding the essence of that reference image before trying to replicate it. But what about the denoising U-net? What does it do in this artistic collaboration?
Well, this unit is like the master painter.
Okay.
It takes the insights from the reference unit and applies them to the line art, meticulously filling in the colors, blending shades, and recreating the style.
So it's this beautiful synergy between observation and execution, guided by the power of deep learning.
Yeah.
Now, you mentioned earlier that MangaNinja goes beyond just copying colors. It's about matching them with incredible precision.
Yeah.
How does it achieve this?
Okay, well, this is where it gets really fascinating. The researchers came up with this technique called patch shuffling. So imagine you take the reference image and cut it into these small squares, like a jigsaw puzzle.
Gotcha, like a colorful mosaic of anime, right?
Exactly.
But what's the point of, scrambling up this visual puzzle?
Well, during training, these patches are shuffled randomly. So it's like giving the model a constantly changing puzzle to solve. It forces it to learn how to match colors and patterns locally, even if the overall structure of the reference image is kind of messed up.
So it's like training, like a detective, to recognize these tiny details, even in a messy crime scene.
Yeah, exactly.
By breaking down the reference image and then reassembling it in tons of different variations, MangaNinja develops this incredible eye for detail.
Exactly. And this patch shuffling is a key innovation that lets MangaNinja do much finer-grained color matching than anything that came before.
That makes a lot of sense. It's like learning a language by focusing on the subtleties of each word rather than just memorizing entire sentences, right?
Yeah.
This attention to detail really sets MangaNinja apart. And it gets us one step closer to AI colorization that's truly artistic.
Absolutely.
But wait, there's more. The paper also talks about a point-driven control scheme.
Oh, yeah.
That adds another layer of control to the whole process. Tell me more about that.
Sure. This is where you, the artist, you can actually step in and kind of guide the colorization process with pinpoint accuracy. Imagine being able to select these points on both the line art and the reference image, saying, okay, I want this character's hair to be like this exact shade of blue from like this specific spot in the reference image.
Oh, it's like having a digital color matching tool.
Exactly.
To make sure everything's consistent across your entire artwork.
Right.
I could already see how this would be super helpful for character design, where maintaining like specific color palettes is so important.
Oh, yeah, absolutely. And it's not just, basic color matching. You can use these points to control how the colors blend together and even like the overall style transfer from the reference image.
Wow, so it's like having a virtual paintbrush that lets you blend and refine the colors to your liking?
Exactly.
This level of control is pretty amazing.
Yeah.
It's like giving artists these like superpowers. They can combine the precision of algorithms with their own creative vision,
Oh, for sure.
But let's be real here. Training a model like this that can do such nuanced colorization, it must take a ton of data. Where did they even find enough anime to, feed this artistic beast?
Well, they went all out. They trained MangaNinja on a data set called Sakuga 42 meter, which has a whopping 42 million anime keyframes.
42 million. That's a lot of anime, even for like a hardcore fan like myself.
It is.
But I can see why they did it.
Yeah.
Anime, with all its different styles and dynamic poses and crazy details, it's like the perfect training ground for a model that needs to learn how to colorize in a way that's robust and adaptable,
You got it. It's like training a martial artist in a bunch of different fighting styles.
Right.
The more styles they know, the better they can adapt to any opponent. And in this case, the opponent is all the different line art styles and reference images that MangaNinja might encounter.
So by like immersing itself in this huge ocean of anime, MangaNinja's become a master of colorization. But enough talk. Let's see this ninja in action. The paper shows some really impressive results, especially in what they call challenging cases.
Yeah.
Situations where previous colorization models would have just given up.
Right.
One example is colorizing line art with poses that are totally different from the reference image.
Okay.
Let's say you have a reference image where a character's arm is like hidden behind their back, but in the line art, the arm is fully extended.
Yeah.
MangaNinja can extrapolate and colorize that missing arm based on the reference image, keeping everything consistent.
Well, so it's not just copying and pasting colors, it's actually understanding the character's anatomy and how they move to fill in those missing details.
It is.
That's next level colorization.
And it gets even better. MangaNinja can handle colorization with multiple references.
Yeah.
So you can use like different reference images for different parts of the line art.
Okay.
You could take like the hairstyle from one character, the clothes from another, and the background from a third image. And MangaNinja can blend them all together seamlessly using those point guides we talked about. So you're basically like creating a Frankenstein's monster of anime fashion. But, in a good way.
Yeah.
It's like having a virtual wardrobe with endless possibilities for character customization.
Exactly. And this brings us to what I think is one of the most interesting parts of this research, the potential for style transfer that goes way beyond just colorization.
Okay.
They've even shown examples where MangaNinja can use a reference image of a totally different character to colorize the line art.
Whoa, wait. A different character? How is that even possible? It's like taking the style of Picasso and putting on a Rembrandt sketch.
It might seem crazy, but it all comes down to the model's ability to match semantic features.
Okay.
It's not just copying colors blindly, it's understanding the underlying structure and meaning of the image.
Right.
So even with a different character as the reference, it can apply the color style in a way that makes sense and keeps the essence of the original artwork. That's insane. It's almost like the model's learning how to speak the language of visual style. It can translate it across different characters, maybe even different art styles.
That's a great way to put it. Speaking of languages, the researchers also realized they needed a common language to evaluate different line art colorization methods.
Right.
They addressed a big problem that's been bugging the field for years, the lack of a standardized benchmark.
A benchmark, so like a standardized test for these colorization models, a way to objectively compare how good they are.
Exactly.
Yeah, I can see how that was missing.
Before this, everybody was using their own data sets and metrics, so you couldn't really tell which methods were actually better.
It's like trying to judge a cooking competition where everyone's using different ingredients and cooking in different kitchens.
Exactly.
No way to have a fair comparison.
But the MangaNinja researchers, they got it. They created this new benchmark specifically for line art colorization.
Nice.
So now researchers can compare their models on a level playing field using the same data and evaluation metrics. That's huge for the field. It's like finally having a universal translator for colorization research, right?
Yeah, exactly.
It's going to be so much easier to share knowledge, compare results, and really push the limits of what's possible.
Yeah.
But I have a feeling they didn't stop there.
This is Talk Tensors after all, and we love to explore those what-if possibilities.
You know me too well.
All right, so buckle up, because it's time for Novel Notions, where we take the research a step further and imagine how this groundbreaking work could be applied and extended.
All right.
I love this part. It's where we get to be like mad scientists and dream big.
Exactly.
Yeah.
So thinking about MangaNinja's ability to handle colorization across different characters,
Okay.
what if we could go beyond static images and apply this to video? Imagine being able to take your favorite anime and reimagine it with the style of a classic Disney movie. Or the other way around, real-time video style transfer. That's a bold idea. It'd be like having a visual DJ for film and animation, mixing and mashing up styles on the fly. I can already see the fan videos and creative projects. But let's be real, that would need some crazy computational power and some real algorithmic breakthroughs.
Of course, it's still just novel notions for now, but that's what makes it fun. We get to explore those what-ifs and let our imaginations run wild.
I'm all about pushing boundaries.
Blah.
But I think we've given our listeners a lot to think about for today.
Yeah, I agree. Let's save some of those crazy ideas for the last part of this episode.
Stay tuned, folks, because the best is yet to come. Welcome back to Talk Tensors. Last time we were really diving into some novel notions like real-time video style transfer for anime. Imagine taking your favorite show and instantly giving it that classic Disney movie look.
Oh, the possibilities are endless, like a visual remix button for animation.
But beyond those big visions, we were also talking about more down-to-earth applications, right?
Yeah.
Remember that idea of a virtual fashion design assistant?
Totally. We were picturing a tool that could, not just help designers visualize their creations, but also analyze things like, feasibility, sustainability, and even ethical sourcing of materials.
That's right. Imagine sketching a design and with a few clicks, seeing how it would look in different fabrics, knowing its environmental impact, even getting suggestions for ethical manufacturing options. It totally changed the game for the fashion industry.
Absolutely. A revolution.
Yeah.
And it wouldn't stop there. What if this tool could even generate sewing patterns and instructions, make it easier for people to make their own clothes?
Wow. You're really thinking outside the box. That's what I love about our Novel Notions segment, pushing the boundaries of what's possible, even if it sounds kind of crazy at first.
Exactly. And who knows, maybe someday these wild ideas won't sound so wild anymore.
Yeah.
I mean, we're living in a time of such fast technological progress. The line between science fiction and reality is getting blurrier every day.
True. Just a few years back, who would have thought we'd have AI models that could create photorealistic pictures from text descriptions or write whole novels?
It's amazing.
Yeah.
And yet here we are. So some of these novel notions might seem like pipe dreams now,
Right.
but I wouldn't be surprised if they became reality sooner than we think.
I totally agree. That's what makes this whole field so exciting. It's constantly moving, changing, pushing past what we thought was possible. But for now, let's wrap up our deep dive into MangaNinja.
It's been a really cool journey getting to see how this model works and imagining its potential impact on art and design.
And for those listening who want to go even deeper, we'll have a link to the full paper in the show notes.
As always, we encourage you to share your own thoughts and novel notions with us on social media. We love hearing from you.
Until next time, keep those learning algorithms running, and may your creative sparks keep on shining.
Farewell, fellow Tensor Talkers.